Hello everyone, I am Amit Maru and today in this video we are going to discuss about knapsack problem using greedy algorithm. This knapsack problem is also known as fractional knapsack problem. So why it is known as fractional knapsack problem, that we will discuss in detail in this video. So let us start our today's video on knapsack problem. First of all, try to understand knapsack problem is. As I said, this knapsack problem is also known as knapsack problem 1, or it is also known as fractional knapsack problem. So first of all, what is a knapsack problem is? So for example, we have a given n objects and a knapsack. We have a number of objects, for example object 1, 2, 3, 4 and 5. So we have, for example, n number of objects and we have one knapsack. Knapsack is nothing but one bag. So we have n number of objects and one knapsack. Every object has some weight and values. For example, this is a first object, then this object has some weight like a 12 kilogram and the value is $4. Same way, this another object has a weight 2 kilogram and the value is $2. This object has a 4 kilogram weight and the value 10. So in this way every object has some weight and value, and we have one knapsack. In that we have to fill this all the objects. So one by one we will fill objects inside this knapsack. Another thing is, this knapsack itself has one capacity constraint. It means that the knapsack can carry a weight not exceeding capital W. So knapsack itself has one capacity constraint like 15 kilogram. It indicates that this knapsack can maximum carry 15 kilogram. And our aim is to fill the knapsack in a way that maximize the value of the included objects while respecting the capacity constraint. Right, again I am repeating what is problem exactly here is, we have a set of objects, we have a number of objects, every object has some weight and value, and we have one knapsack, that is a bag, and bag itself has one capacity constraint, that is capital W. It indicates that this bag, this knapsack can maximum carry capital W kilogram. So when we fill a different object, at that time we need to check that the total weight must not be more than the capital W. In this case 15 kilogram is a capacity constraint of this bag. It means that we cannot fill object which has a total weight more than the 15 kilogram. So up to 15 kilogram we can fill different objects. Once it is 15 kilogram or more than the 15 kilogram, then we have to stop. Right, so more than 15 kilogram weight we cannot store inside the this bag, or we can say inside this knapsack. Now our goal is we have to fill this knapsack in such a manner that we can maximize the total value of the included objects. So it means that we have to choose object in such a way that so that the total value of this bag, or we can say the knapsack, must be maximum value. It means that we have to identify the object which has a maximum value. For example, this object has a $10 value, so definitely we have to fill this item, or we can say object, inside this bag. Then we have to identify the next object which has a maximum value, for example 4, then we can fill this knapsack, but the total weight is 4 plus 12, that is 16, which is more than the 15. So now we cannot fill the object, total weight must not be more than the 15, so that we cannot fill this whole object, but some part of this object we can fill, and so that it is also known as fractional knapsack problem. Right, so in this first version of the problem, we assume that the object can be broken into smaller pieces, so that we may decide to carry only a fraction xi of the object I, where 0 less than or is equal to xi less than 1. It indicates that either we can fill a full object, or we leave behind the object, or we can also divide our object into small piece, small parts, and some parts of that object we can fill inside the knapsack. Every time we need to check the total weight must not be more than the capacity constant capital W. So in single line we can write like maximize the total value xi vi, I starting from 1 to n. So first time is x1 v1, it indicates that the value of first object. Whenever is x2 v2, it indicates that value of second object. So we have to maximize total value subject to the total weight must not be greater than capital W, or we can say it must be less than or is equal to capital W. So the total weight of the knapsack must not be more than the capital W. It should be less than or is equal to capital W, which is capacity constant of the knapsack. Right. So let us take one example so that you can easily understand. Suppose we have one knapsack and we have n number of objects. And every object has, as we discussed, has some value and weight. So this is the value and weight of our object number 1. So object number 1 has a weight 10 and value is equal to 20. Object number 2 has a weight 20 and value 30. Object number 3 has a weight 30 and value 66. Likewise 40, 40, 50 and 60. And the capacity constant of our knapsack capital W is equal to 100. It means that our knapsack can carry maximum 100 kilograms, and we have to fill our knapsack in such a manner so that we can maximize total value of the knapsack. So we have a different solution, and we will discuss one best solution that is our greedy algorithm. So let us have a different solution. For example, if we select the object in order of decreasing value, so definitely in short-sighted method or short-sighted mind, we can select this option. This option says that we have to select object in order of decreasing value. It means that we have to choose the object which has a maximum value. So for example, in this list of object number 3 has a maximum value, that is 66. It means that we have to fill this object first. Then after last object, and then after fourth object, then after second object, and then after first object. It means that in order of decreasing value. This is the first choice. We need to verify what will be the total value of the object. Another option is if we select the object in order of increasing weight. It means that we have to select object which has a minimum weight. So we can choose the 10 first object, then after second object, then third object, then fourth object, and then after fifth object. But every time we need to check total weight must not be greater than 100. It must be less than or is equal to 100. Now third option, that is our greedy method, and greedy method says that if we select the object in order of decreasing, Vi divided by Wi. So this is nothing but ratio of Vi divided by W, that is our value and weight. If we divide V by W and find the value, for example 20 divided by 10, then 2, then 30 divided by 20, then 1.5, then 66 divided by 30, 2.2, 40 divided by 41, and 60 divided by 50, that is 1.2. And if we select the object in order of decreasing Vi divided by Wi, in decreasing Vi divided by Wi, it means that we can select 2.2 first, or we can say the third object we have to select first, then after first object because 2, then after second object 1.5, then after last object 1.2, and then after fourth object, that is which has a value 1. In this way we can select, and this is actually our greedy algorithm which give best solution. So let us check every option first. First select object in order of decreasing value and find out what is total value of the knapsack. Let us solve by using these three different options. As per the first option, if we select the object in order of decreasing value, it means that we have to identify the object which has the largest, or we can say the maximum value. So in this case our third object has a maximum value, that is 66. It means that we have to select first third object. So select third object. First select object number 3. When we select object number 3, at that time the value will be 66 and the weight of our knapsack will be 30. Right, so now total weight of our knapsack is 30. We have selected only one object, that is third object, and the value of knapsack is 66. Now select next object which has a maximum value. So our next object, that is fifth object, which has a value 60. So select second object, that is object number 5. And then the value of this knapsack and value of this object is 60 and the weight is 50. Every time we need to check total weight must not be more than the 100. So total weight of our knapsack is 80, which is less than the 100. It means that still we can fill our knapsack by any object. Now select a third object which has the highest value. So first we have selected a third object, then after fifth object, and then we can select our object number 4 which has a weight and value 40. So select object number 4 which has a value 640 and the weight is equal to 40. Now we need to check the total weight must not be more than the 100. Here total weight is 120, so it is not allowed. The total weight now must not be more than the 100. Right now it is 120, so it is not allowed. So we have to do something. We cannot fill last object full object, because last object has a weight 40 and value 40. So we cannot fill our full object here. As we discussed, we can divide our object into different parts. So let us divide our last object number 4 into 2 parts, so that your weight will be 20 and value will be 20. So here once we perform addition between these two numbers 30 and 50, then the answer is 80. So how many maximum parts, or we can say the maximum 20 weight we can fill in this case. So out of 40 we can fill 20, so we have to divide into different 2 parts. So weight will be 20 and value will be 20. So 20 and here weight will be 20. It means that half of the object we are using to fill the knapsack, and total value of knapsack will be 146 and the total weight will be 100. So this is the answer here. In this case, when we fill the object, when we fill our knapsack in order of decreasing value, at that time maximum value of the knapsack will be 146, that you need to retain. Now another option, that is if we select the object in order of increasing weight, it means that we have to select object first which has a minimum weight. So select object number 1 because it has a weight 10 and the value 20. Then select object number 2 which has a weight 20 and value 30. Here the total is 30, so still we can fill our knapsack by using different objects. Select the third object, select object number 3 which has a weight 30 and value 66. Total 10 plus 20, that is 30, 30 plus 30 60. Still it is not more than the 100, so we can fill our knapsack by using different other objects. So select object number 4 which has a value 40 and a weight also 40. So total is 10 plus 20 30, 30 plus 30 60, 60 plus 40 100. Now we cannot select any object to fill the knapsack because total weight is 100 and the maximum 100 weight is allowed. So find out total value in this case. Then the total value is 156 and the total weight is 100. So this is the better option than our first option, in that we have solution that is 146. And right now if we select object in order of increasing weight, then total value of the knapsack is 156. So this is better one. Now our last option, that is our greedy algorithm. Here we will select object in order of decreasing Vi divided by Wi. It means that we have to identify Vi divided by W for every object. So first we have to identify V divided by W for first object. So 20 divided by 10, that is a 2.0. Then 30 divided by 20, that is 1.5. 66 divided by 30, that is 2.2. 40 divided by 40, 1.0, and 60 divided by 50, that is 1.2. So identify V divided by W for every object, and we have to select object in order of decreasing Vi divided by Wi. It means that we have to identify, or we can select object which has the highest value of V divided by Wi. So among these all the objects, the maximum value is 2.2. It means that first we have to select object number 3, then after object number 1, then after object number 2, then after object number 5, and then after object number 4. Every time we have to verify the total weight must not be more than the 100. It must be less than or is equal to 100. Right, so let us fill our knapsack using this Vi divided by W, that is Y greedy algorithm. So now first step is we have to select object. So as we discussed, we have to select object number 3 because has a value V divided by W 2.2. So first select object number 3. Then the knapsack has a value 66 and the weight of the knapsack will be 30, which is less than the 100. It means that we can select another object. So our next choice will be object number 1 because it is a 2.0. So select object number 1. Then the value of knapsack will be 66 plus 20, that is 86, and the weight will be 30 plus 10, that is 40. So 40 is less than the 100. So we can select another object. Now next object that we need to choose, that is our object number 2. So select object number 2. Then the total weight of the knapsack will be 30 plus 10. 40 plus 20, that is 60. So 60 is again less than the 100. So again we can fill another object inside the knapsack. So next choice, that is object number 5. So choose object number 5. Then the total weight will be 30 plus 10, 40 plus 20, 60. 60 plus 50, 110. Which is more than the 100. It means that so we cannot fill our last object fully, otherwise it will be 110, which is larger than the capital W. So we cannot fill our last object fully in this case. So here total value is 170 and total weight is 110, but 110 is not allowed. So we have to divide our last object into different parts. As we discussed, this is a fractional knapsack problem, in that we can divide our object into different parts. So as per the requirement, here total value up to this object number 3, that is 30 plus 10, 40 plus 20, that is 60. So out of 50 we can choose 40 only, so that total weight will be 100. So we can not select full object, but eighth part of the object we can select to fill the knapsack, right? So eighth part means 50 multiplied by 0.8, so it will be 40, and 60 multiplied by 0.8, so it will be 48. So just take eighth part of this object number 5, then we can get 40 here, and the value will be 48. So the total weight of the knapsack will be 100, which is allowed, and total value will be 164. Right, so we discussed 3 different options. In our first option, in that we have to fill the knapsack by decreasing order of value, then we are getting answer, that is 146. In second option, in that we are selecting object with minimum value of object, minimum weight of the object, then we are getting answer, that is 156. And in last, that is our greedy method, in that we are selecting object in decreasing order of Vi divided by Wi, and we are getting answer, that is 164. 4. So when we discuss our first option, in that the 0 indicates no object. Object number 1 we have not selected, object number 2 we have not selected. We have selected object number 3 fully, object number second we have divided into different parts, so half of the object we have selected, and the last object we have selected. In our second option, we have selected first object, second, third and fourth object, and we have a total value 156. As we discussed in our last, that is Vi divided by Wi, we have selected object number 1 fully, second object fully, third object fully. We have not selected our fourth object, and eighth part of the object number 5 we have selected. So the total weight will be 100 and the value will be 164. So when we compare the answer of these three options, then we can say our last one is better, because which has a maximum value, that is 164, right? So when we select object, at that time we have to select based on our last option, that is we have to select object in such a manner so that we can maximize the value. And as we discuss in this table, we can say that we have to select object in order of decreasing order of Vi divided by Wi, so that we are getting answer that is 164, and this is the better answer. This is all about our knapsack problem by using greedy algorithm. So here we can divide our object into different parts, so that this knapsack problem is also known as fractional knapsack problem. When we think about the analysis, or we can say the time complexity of this algorithm, then we can say implementation of the algorithm is straightforward. If the objects are already sorted into decreasing order of Vi divided by Wi, then the greedy loop clearly takes the time, that is order of n. But the total time including the sorting is therefore n log n, because to sort this list of number into ascending or descending order, it takes maximum n log n time complexity. So the total time complexity of this algorithm is also order of n log n. So this is all about our knapsack problem 1 by using greedy algorithm. So thank you very much.